So the difference between a PLC and a PLD is that with a PLC, you have to essentially manually create every bit of logic in it. With a PLD, it's built in. Does that make sense to everybody? Okay. So CAD, we use CAD. Who knows what CAD is? Or what it stands for, rather? Anybody?
Computer aided something.
It's computer aided design, yes. Computer aided design. Y'all might want to memorize that particular bit of information because CAD is one of those acronyms that's a good idea to know. Okay. So we use CAD to draw schematics. We have different things like schematic capture to convert binary files to alter a PLD's connections. And then we have integrated circuit hardware to make it all come together. All right, so how do we make this flow? Well, it's kind of like any scientific method. What's the first step of the scientific method? Does anybody remember science class back in elementary and middle school?
You can make a hypothesis.
You gotta make a hypothesis. First step is always hypothesis, right? Without a hypothesis, how are you going to be able to test it and make sure you get the results you want? Right? So the first one you have to do is define the problem. Is there an actual problem, or is it just something that can be fixed just with a little bit of time? So what is the problem? Then you develop equations or you develop ways to solve said problem, right? So then you enter the design or create the experiment, test the experiment or simulate input-output conditions, set the experiment as done, and then do a final testing to make sure everything went as it should. Did all that make sense to everybody? So basically it's the scientific method, but in this case you're not using the scientific method to create an experiment, you're doing it to create a program. Okay. So if you're a maker of PLCs, do you think you probably need to know how to know what you're doing? Because the first thing you got to do if you're programming that PLC is you've got to first of all determine what?
What you want it to do?
What you want it to do. It's kind of useless if you don't have something for it to do. Right? So then we have SPLDs, which are the most basic, least expensive gates. Now, you always want to be careful what you get because anytime you go for something that's less expensive, it sometimes isn't better quality. But yes, SPLDs are the most basic, least expensive configurable logic gates. It has more than 12 inputs and more than 10 outputs, simply because it gives you a bigger range to have, and I'm stumbling over my words today, excuse me. More than 12 inputs and 10 outputs to be able to get what you need from it. So before we go any further, it's talking about here it is mentioning AND gates. What are AND gates again, guys? Just kind of see if everybody remembers.
There has to be 2 inputs to get an output.
Okay. Minimum of 2 inputs for an output. What are the other logics?
Or, nor. And then NAND.
So you have AND, or, not, NAND, nor. And then one less talked about is the one I like to call memory. That's where the circuit will seal in until you tell it unseal. Okay. Any questions on that? So just kind of a quick recap. What is the job of a NOT gate or NOT switch? NOT logic, however you want to call it. What is the real purpose behind it? Or where would you see it most commonly used is another question I could probably phrase that as. Yeah. NOT gates.
Diode. If the input is high but the output is low.
For a NOT gate, what you're actually looking at is it's an e-stop more than anything. In other words, it's reverses the logic. Okay. So it's the best way I can tell you about it is that it's an e-stop. It's emergency stop. In other words, the gate is open until you slam that door closed and tell it no, you can't pass. Best way I can describe it off the top of my head right now. Okay. So we have programmable logic arrays, which are worked with OR gates. Then you have PLAs, which so PALs and PLAs are both programmable logic arrays or array logic that use OR gates. One are programmable OR gates, one are not. One is not. Allows us to flip-flop memory sections and things like that. Excuse me. CPLDs, or complex programmable logic devices, combine programmable I really get into to alphabet soup here. Programmable array logic types with the others into a single package. It creates non-volatile memory. What's the difference between non-volatile and volatile memory?
One stays after the power's off, the other one doesn't.
That's one good way to say it. What's another? What about humans? Do we have volatile and non-volatile memory?
Yeah.
Okay. So volatile memory for humans, what is that? What's the closest thing we can call it? Long-term or short-term memory?
Short term.
Short term.
Volatile is short-term memory. Non-volatile is long-term memory. Does that make sense to everybody?
Yes, ma'am.
Okay. So we have field programmable gate arrays. So using PLDs, programmable logic devices, to solve basic logic designs. There's several different editors and compilers you can use, different simulators. What you're going to run across with some of this is that if you're having to reprogram something, you need to have the correct software. So for those of you that have been in PLCs, can you use a Siemens programmer to program an Allen Bradley?
No.
No, you can't. It's two different operating systems, even though both are PLCs. Okay. But a lot goes into designing circuits. Makes it very interesting. All right, guys, let me go ahead and say this real quick before we summarize this first chapter, and I'll let y'all take. We don't need a break just yet, but let me go ahead and say this. Starting next week, y'all need to be on campus because we will be doing labs starting next week, just so that we can kind of catch up and be where we need to be. So please do plan to be here next week. All right.
Yes, ma'am.
Okay, because we'll be going into lab next week. Go ahead and get some of this started knocking out, and that way y'all have some hands-on practical practice with some of this. Okay. So programmable logic devices can be used to replace uh, ICs. They are so those are so integrated circuits. So programmable logic devices can be used to replace integrated circuits. They contain thousands of logic gates. So to configure them, we use CAD, computer-aided design, to implement that logic. Because if we don't know what we're doing, do we need to be messing with it? Probably not. Simply because that can lead to some problems down the road, right? If you're going in to mess with something like that, you need to be real careful. So we have schematic entry and VHDL entry. So schematic uses CAD to draw the logic that needs to be implemented. The other one uses uses text editor to write the program descriptions, defining the logic to be implemented. So in one, you are building literally something in the computer that can be created a physical thing. And the other one, what you're doing is basically writing out the instructions that you're wanting it to follow. Does that make sense to everybody?
Yes, ma'am.
Okay. So PLD software includes logic simulators. So that allows us to make sure that it's not going to be buggy whenever we actually set it up, right? Because worst case scenario and worst nightmare scenarios generally what? Flip that switch and something goes horribly wrong, right? That's what we try and prevent because we don't want accidents like that. Okay. So most PLDs are erasable and reprogrammable. This allows the user to test many versions of their logic design without changing the integrated circuit. Now, why would that be a really great thing to do?
If you want to make updates to the software by any chance, you can try new add-ons without even changing it. Because you don't want to mess up the original design because the add-on may not work out for you or the user's intentional purpose for it.
Very much so. Thank you very much. Exactly what he said. Being able to have things in manufacturing that are flexible, multi-use, or multi-purpose, however you want to call it, is pretty much key to how manufacturing works these days. Because manufacturing, you have to be flexible to based on customer demands and what kind of product they're wanting and how you are going to plan to make it. If you don't have things flexible enough, then it can make it really hard to do well in business. Make sense? So kind of keep that in mind. Change is not a bad thing. Much as many people don't like it, change can be pretty good for whatever is going through and making it to where everything becomes more necessary. I guess you could say. Okay. So basically, there are three types of PLDs. You have SPLDs, CPLDs, and FPGAs. The first ones are several multi-input AND gates that feed the inputs to OR gates and memory flip-flops. The CPLDs contain several interconnected SPLDs, and the FPGAs is the most dense form of the PLD and solves its logic using a lookup table to determine the desired output. In other words, it allows it to kind of think on its own just a little bit. All right,